I'm going to teach you how to solve a calorimetry problem. Calorimetry is used in chemistry to measure the heat exchange between substances. This is an example of a calorimeter. 2 coffee cups, which are good insulators of heat, and a cover. A thermometer is placed inside to get the temperature, and you have a stirrer to maintain heat balance. In chemistry, a calorimetry experiment is used to find the identity of a metal. This is how the experiment works. You get the mass of the water inside the calorimeter. You get the initial temperature of that water. You get the mass of the piece of metal, and then you heat it to a certain temperature and you record the initial temperature of that metal. You place it in the calorimeter and quickly close the lid. When the system's temperature has reached equilibrium, the temperature of the metal will equal the temperature of the water. The heat transfer occurred between the metal and the water. The heat that was lost by the metal was gained by the water. And so you could equate two Q equations to each other. Okay, the negative Q of the solid of the metal equals the Q of the water. And so the negative mass of the metal times the specific heat of the metal times the change in temperature of the metal equals the mass of the water times the specific heat of the water times the change in temperature of the water. Let's solve a calorimetry problem together. 100.0 grams of nickel at 150 degrees Celsius was placed in a 1.00 liter container of water at 25.0 degrees Celsius. The final temperature of the water was 26.3 degrees Celsius. What is the specific heat of nickel? And the density of water is 1 gram per milliliter. Well, the heat that was lost from the metal was gained by the water. So negative Q of the metal, I'll put M for metal, was equal to the Q of the water. I'll put H2O for water. Okay, so we write out this equation. So Q is equal to mass of the metal times specific heat of the metal times change in temperature of the metal, which is equal to the mass of the water times specific heat of the water times change in temperature of the water. We are solving for the specific heat of the metal, which is Cm. So let's rewrite the equation solving for the specific heat of the metal. So negative specific heat of the metal is equal to mass of the water times specific heat of water times change in temperature of the water over negative of mass of the metal times change in temperature of the metal. Now let's plug in the values and solve for the specific heat of nickel. Mass of the water. Well, you're given the volume of the water, 1 liter. We have to convert the liters to milliliters and then multiply by the density to find the grams. And so mass is equal to density times volume. The density is 1 gram per milliliter, and the volume is 1,000 milliliters. And so the mass is 1,000 grams. Let's plug that into this equation here. 1,000 grams of the water times the specific heat of water, which is 4.184 joules per gram degrees Celsius, times the change in temperature of the water. So 26.3 minus 25.0. So final temperature of the water minus initial temperature of the water, and that is 1.3 degrees Celsius. We're going to divide that by the negative mass of the metal, which is 100.0 grams, multiplied by the change in temperature of the metal, which is 26.3 minus 150, and that's negative 123.7 degrees Celsius. You multiply the top and you get 5,439.2. On the bottom, you would get 100 times negative 123.7 times negative 1, and so you get negative 12,370. When you divide these two numbers, 5,439.2, divide that by 12,370 negative, you get negative 0.439. And then you divide by negative 1 here, and you get 0.4397. We'll round that to two significant figures, because 150 is the least number of significant figures. So 0.44, and the units for specific heat, the units that don't cancel out, is joules per gram degrees Celsius. So this is the specific heat for nickel. Thanks for watching. Please like, comment, and subscribe to see more chemistry videos.